Today our lesson is on motion in the ocean. What are ocean currents? An ocean current is any more or less permanent or continuous directed movement of ocean water that flows in one of the Earth's oceans. Currents are generated from the forces acting upon the water like the Earth's rotation, the wind, the temperature and salinity differences, and the gravitation of the moon. Are there different kinds of currents? Yes. Surface currents and deep water or density currents are the two major types of currents. Surface currents. These waters make up about 10% of all the water in the ocean. Winds move the top 400 meters of the ocean, which creates the surface currents. The water at the ocean's surface is moved primarily by winds that blow in certain patterns because of the Earth's spin in Coriolis effect. The Coriolis effect is when circulating air is deflected toward the right of the northern hemisphere and toward the left of the southern hemisphere. This happens because Earth rotates on its axis. Along with other forces, the surface currents also form large circular patterns called gyres. An ocean gyres is a large system of circular ocean patterns formed by global wind patterns and forces created by Earth's rotation. The movement of the world's major ocean gyres help drive the ocean conveyor belt. The ocean conveyor belt circulates ocean water around the entire planet, which brings us to our second type of current. Deep water or density currents. These waters make up the other 90% of the ocean. These waters move around the ocean's basins by density-driven forces and gravity. The global conveyor belt is driven by density differences in the water. One must better understand density to understand how density current works. So what is density? Density is a characteristic property of a substance. The density of a substance is the relationship between the mass of the substance and how much space it takes up. The mass of atoms, their size, and how they are arranged determine the density of a substance. Density equals the mass of the substance divided by its volume. Objects with the same volume but different mass have different densities. Which weighs more, a pound of feathers or a pound of lead? The answer is in the question. A pound of feathers is equal to a pound of lead. They both each weigh a pound. What's the difference between a pound of feathers and a pound of lead? The difference would be their density. Think of density as the measure of the compactness of the material, how close the atoms or molecules are to each other. More than heaviness, density includes how much space an object takes up. All substances have density, including liquids, solids, and gas. Now that we understand density, we need to better understand density currents. Water movements driven by differences in density are also known as thermohaline circulation because water density depends on the temperature and salinity. The thermohaline circulation is sometimes called the ocean's conveyor belt, the Great Ocean Conveyor, or the global conveyor belt. Let's see how it all works. Do the ocean's currents impact you? Yes, more than you think. Ocean currents help regulate temperature and weather and are very important to both humans and animals. For example, the Gulf Stream moderates London's temperatures. Without the current, London would experience extreme and very cold weather. If the Gulf Stream were disturbed, it would affect many lives. Currents also cause upwellings. Wind and ocean currents work together in upwellings, the phenomenon of cold, nutrient-packed water pushing to the surface. It forms the basins of the ocean's food chain that attracts marine life from dolphins to seabirds while creating incredibly robust fishing grounds. Now that you have learned about ocean density, we have an experiment we would love for you to watch and maybe try at home with a parent.
So today we're going to be doing a density experiment. For this experiment, the materials you will need is 2 clear cups with fresh water from the sink. Then you will need 2 raw eggs, a spoon, and salt, and then 2 different color food colorings. It doesn't matter what color they are, just 2 different ones. So first you need to do is add your raw egg to your fresh cup of water. Bloop. Now you want to add 4 tablespoons of salt into your other fresh cup of water. That's 1. Whoop. 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 Then you get your spoon and you stir it up and make sure it dissolves fully. So after you dissolve the salt in the water, get your other raw egg and drop it in the water. So you see the egg floats on the top of it. So why did the egg sink in the fresh water but float in the salt water? In the fresh water, the egg has more matter stuffed into the specific area than the same amount of water. When you add salt to the water, you increase the density. With enough salt added to the water, the density of the water is greater than the egg, allowing the egg to float. Now, we have a glass of salt water and fresh water. We are going to add blue coloring to our fresh water and red coloring to our salt. So, first, we're going to remove our eggs before we put the food coloring in. Okay, so in the fresh water, you add just a little bit of food coloring to it. Okay, now you get red food coloring to the salt water. Add a few droplets. Okay. Now we stir it. So, now that we have the food coloring in, what will happen if we use a small amount of fresh water to the salt water? So, when you pour the fresh water in, tilt it slightly, just a little bit at a time, because it might make the fresh water too much and the density would not be. Okay, so you see, the fresh water almost floats at the top of the salt water. But if you don't see that, just pour a little bit more. Okay, so now we see that the salt water is denser, causing it to sink to the bottom. So now you see that the fresh water is floating on top from the salt water.